This is module E1.8, Extending and Consolidating IT-Enabled Engineering Practice. It's about how IT has provided enablers in your workplace previously, what you might introduce now given the present situation in IT, and what possible future changes might happen that could also be introduced to improve the workplace production, processes or outputs. So what you will learn in this course is from the lectures you'll get a framework for your investigations into the role of information technology and engineering. Then you'll use this to consider how IT acts at present as an enabler in your workplace, and this will be your first assignment, to discuss something that's used now in your workplace. Then I want you to understand that the success of an IT tool in engineering is judged by whether the tool is able to produce an organisational outcome. These tools do not have value in themselves. It depends on what they can provide to the industry. So we don't want you just saying, well, this is a nice, cool tool, I'd like to use it at work, introduce it. We really want you to understand why you're introducing it and what the benefits are. Now, all links provided in this lecture are supplied in the reference section in UCS Online under this module, so you don't have to try and get them off the video. Now, for this module, you will have 3 assignments and some group discussions. In the assignments, you will provide a history of one aspect of IT that is used in your workplace and how it enables better work practices or increased productivity. And you'll present that as your first assignment. Then we want you to investigate and propose an implementation of new software practice into your work. So it might be using an existing product from another area and applying it to a new area, or it might be how you could develop a totally new product. You'll have peer support with this, and you'll work with your supervisor to evaluate this initial proposal to see that it's feasible. And during your continue to work in your internship, maybe introducing this proposal or evaluating what would happen if it was introduced. And you can provide the evaluation of its possible success or not at the end of your project, and how you might best implement the change to enable this IT product to be used. It might require training, it might require investment, it might be a lot of features that might be required to get this software in place. So in engineering, what can software do for you? There is an enormous amount of types of software available that do quite different things, so it's worth trying to narrow down at first what sort of area you want to look at. The point of IT is that while it is an engineering type of subject, it has one basic difference to engineering. In engineering, if you're designing a building, you have certain concrete specifications, requirements for different sizes of heights of buildings, different sizes, different reinforcement rods and sizes and numbers required. There's fairly standard processes that are used that are understood to be the minimum requirements for building a building. Similarly, in electrical engineering, you want to build a circuit, say you need an amplifier, there's say 10 amplifier chips available. 4 of them will satisfy the noise requirements for your particular circuits, will fit the particular earthing that you have. So you've got a choice of 4 particular amplifiers, and again they will have different specifications that will or will not fit your circuit board, and there's probably not much flexibility. There's probably about only one chip that you can use in your particular design. So you every time you do a design of this sort, you use that chip. There's not much choice in engineering. In software, what you're developing is based on the English language. Most script coding is in pseudo-English. Therefore, the options are about as flexible as a language. And so this is what we'll try to do in this lecture, is provide you some framework to narrow down the types of software that you might look at and the areas that you will consider. So the first image, the LinkedIn map, is an image for data analysis. If you want to provide your customers or your staff with very quick analysis of data, help them see the patterns in the data, there's various tools, particularly graphical tools, that are useful for providing a really good overview of data and helping you extract the patterns. And the visualization enables the human mind to much more quickly see these patterns. Then there's a lot of data manipulation tools. The Excel is a very simple in one way, but can be very complex system. Excel charts for analyzing data. You can do a whole lot of data within these charts. You can extract data from various other platforms and import them and manipulate them and then export them again. So it's a very flexible tool, but these sort of data manipulation tools are very useful and also can be used for a tracking process like a check sheet sort of style chart. Have you done all the required processes for risk management? All these sort of things. So there's a lot of applications. And the third category I put here is the idea of a scripting tool. So things like MATLAB and Maple, they allow you to write scripts to run on data. So you have the data there, you run it, you might generate the data with an equation, then you can run analysis on that data and visualize it. So it has the visualization aspects, it has the data manipulation aspects, but also has a scripting aspect where it allows the user to set up a script initially and then modify it, rerun it with new data, and it simplifies the process of very complex analysis. So these sort of tools are very useful. So the structure of the module is sort of as I've run through already, but we want you to first consider the history of IT and the discipline of your internship. Focus on one major change that was initiated in your area through the introduction of IT, and write a short report on why this happened and what was the outcome. Then consider if the same IT development would be appropriate now, or something else would be developed given the present business needs. So when in this first history analysis, we want you to consider, well, in an alternate history, if you started this development of this new tool now, would it be different, or was the most suitable tool still? This will help you into your second stage, where we want you to monitor your work practice for the first 4 weeks of your internship and note any possible IT applications to improve your work. You should focus on business needs, such as improvement in sustainability, improvement in efficiency, effectiveness, or accuracy. And these should be what drives your software development. As I said before, software doesn't have value in itself, it has value in how it satisfies user needs. In this case, the user is your organization and the employees. Then you will discuss with your peers in your assigned group what you think are the options for introducing IT and assess each of these options, and then write up a report on your proposed changes. So we'll give you time to discuss with peers. You don't have to, but we recommend it so that you get some good range of solutions for or a good change to propose for introducing IT into your workplace. Then we'll give you some time to consider how that would be implemented. For instance, would it require training? Would it require large investment, more machinery, and these sort of things? And then maybe therefore you might need to delay it. Would delay it because of cost, delay it because the actual software isn't quite ready yet, it's not quite that sophisticated. So we want you to do a final report with an in-depth analysis of what would be required for managing the change in IT that you're proposing, and how likely you think that this change will be taken up in your area or your organisation, considering the history that you studied at the first submission. Then consider if there's a way this change could be even better in future as technology develops. Now, in looking at the history of information technology for your first assignment, we want you to look at various aspects as possibly being relevant to your workplace. So you don't have to cover all these, but this gives you some idea of sort of a guide for what you might look at to understand IT and its uses. Firstly, looking at the history of availability. Computers used to be large mainframes in air-conditioned buildings that were accessible to staff, probably trying to reduce dust coming into the room, very clean environments, and they were very precious and fragile instruments. Now you have a PC, a laptop, you probably drop regularly, and sometimes it recovers, and it's available in your own home without air conditioning. In fact, it can work on the back seat of a car in the desert of Australia. So the availability has increased dramatically. but also the applications you can run on a computer have increased. We used to mainly have standalone programs, or only had standalone programs initially, and because the computer was an empty, isolated entity. But as it linked to the internet, you could then combine computers in your program, such as the SETI search for aliens, or through the internet you can actually run programs on other people's computer on a large mainframe. So you've got access to the computing power of these large systems, or you can even have access to robots. You can control robots remotely. And so it's changing rapidly in terms of availability. And also the functions that are available. Initially, computers basically ran mathematical formulae. Then there was provided a more visual display that wasn't just text. It could be pixels, a graphical image. Um, Text was pixels, but this is much more sophisticated visual displays. Then you started to get on the internet. You'd have websites that were static material that then could be updated, or forms could be filled in from another place. So that was an interactive interaction. You're interacting with a database through these various functions, and it was become a collaborative effort to create material. And then you start getting intelligent services where part of the collaboration is the computer. The computer provides software that is highly sophisticated and intelligent, can do pattern analysis, can analyze the actions of the user or the data that's stored, and provide extra enhanced information and services to people on the internet. And the way software is developed has changed. It used to be probably mostly commercial, or research, where some company would develop a product and try and sell it, and then another company might try and develop a similar one and outsell it. Then companies would start developing computing software for themselves, for in-house, and then it might become a commercial product sold outside, but be mainly useful for their own industry. So therefore very specialized and focused. And then it became open source, where software was maybe developed for a particular application, but because it was open source, anyone else could take the functionality, the methods that are used in it, and reapply them to another area. So it became very flexible, and also it was free. So you got this change both in sort of the pricing in terms of commercial being for sold externally, in-house being just the cost of the personnel in company developing it. And now open source, it's free because some nice person has taken the effort to develop this and share it around. But also the type of software that's developed. Initially, they were very specific for, particularly in-house ones, were very dedicated to a particular application, whereas open source might be written for a particular application, but designed to be embedded in with other modules and into a lot of different applications, particularly like the JavaScript's used for visualizing data. There's D3 libraries that you can get that you can plug them into your website and they will visualize data for you on the website. So there's an extraordinary amount of flexibility available now. And the scope is that, I sort of covered this, you could start with specific application where you write a bit of software that does this job. Then you started developing a system of tools. So some people might use this part of the software program, some use other parts. So there's these separatable tools or modules that you could then plug in and use whichever you wanted. And then it became scripted languages where you could say, well, by script I can call particular modules. So I want to draw a function, I want to find the mean, and I write the script that tells the program to do these particular steps. So in effect, each step of the script is calling different modules according to your needs at the time. So it's very easy to set up which tools you use at any time. So in the technical aspects too, there's been lots of changes. There's the storage speeds. We've now gone to solid state storage, which is much quicker. The solid state is much smaller usually, but we're starting to increase the size of solid state storage. So we're increasing storage speed and size. The CPU calculation speed, the rate of the clock for calculations is increasing rapidly, so that we can now analyze large amounts of data on our large storage devices with our rapid CPU calculation, and instead of, say, collecting the data from one day, putting it to analyze it to find the financial market patterns for that day, you could leave it to analyze overnight and the next day say, okay, well, was the result. Now you can do it in real time. So you're getting the data in real time, you're number crunching it, you're finding that the sentiments of these news reports relate to the pricing at this market, and you can start making predictions in the financial market based on that. So the types of data available is also rapidly increasing, as well as data collected from people's profiles, people's forms they put in. We've got sensor data, so sensor locations becoming the Internet of Things is amplifying enormously the amount of data that we have available to analyze. And of course, the personal data is expanding rapidly too as more people get on the Internet, and this data is available, but maybe it should not be analyzed. And the security issues arise out of, particularly with the Internet, that who has access to what, but even in your workplace, who has access to what data, who should be able to see clients' data, what sort of protocol should be around that to prevent client data being discussed or leaked out, and it becomes a major concern of computing because of the openness and availability of data. So when you look at the history of an IT application engineering, we want you to, we were providing these case studies to assist you in that process. So the following sections discuss previous IT solutions in the engineering area that you can then maybe consider one of these or any other one you find suitable. So while these case studies aren't in historical order, they provide a range of solutions that have been introduced into engineering that you can use as examples and consider. So you might see what might be now useful now in your workplace for your second assignment too. And these resources and more information are all on UTS Online under the resources folder, and they cover each of the topics covered in the following slides, so it's all there online after you've seen this lecture. These case studies raise various issues when planning to introduce IT into your work, as well as provide different ideas of what can be done. So I bring up some of the issues and concerns, as well as different ones in different case studies. So the case studies that we'll cover are supporting new system approaches, how you design your system, how you run your system in sustainable engineering. There's tools to assist in this. Improvement project communication, information sharing from email and text to various other tools. Global research support, how you can research and share data globally. Heightened professional productivity, how to improve professional productivity. This is like amongst your particular industrial area or in your workplace. Maybe it might be a global workplace. Looking at rationalized capability management. Now we're managing people's skills rather than physical resources, and so that's a different type of management. Big data, as I've referred to often, is a very important area. New risk management thinking. What are the risks now in industry? What do we need to avoid? There's things like conflict resources. So you have to consider that if the resources that you're using in your development are brought from a conflict zone, is the money from this purchase being used in a war? And what sort of risk are you taking by enhancing war in the world through your industry? So there's a lot of more risk to be thought about, and risks in terms of sustainability or non-sustainability of your products. There's a lot of enhanced and alternate modeling options such as MATLAB and Maple. There's simplified documentation, tracking control, a lot of software and tracking control, particularly of software, but also of hardware. You can look at new products and services introduced recently, such as software-defined radio, and also consider workplace freedoms. What sort of freedom do you want to support and allow in your workplace, and how can you enhance that with IT?